Hello everyone, I am Suchita Modi. I welcome you all in the video lecture on the topic Properties of Z Transform Part 1. Z Transform mainly used for discrete function. And now applications of Z Transform in different fields. In mathematics and signal processing, Z Transform converts a discrete time domain to a frequency domain. And applications in different fields, that means in digital filters, digital signals, in linear discrete system, simulation of continuous system. One of the major application of this is as an analysis tool for discrete time LTI system. LTI means linear time invariant system. For finding the frequency response and evaluation of the stability of discrete time LTI system, then the transform is used and main role in the discrete analysis, that means this is the communication, is one of the field whose development is based on the discrete analysis. Now we start with the sequence. The sequence f of k is a order list of real and complex numbers, and representation of these is given by two types. First is listing method. Therefore here f of n equal to this sequence which is given by equation 1, and this symbol upward arrow which denotes the zeroth position at n, that means at n equal to 0. This f of n, g of n, observe this equation number 1 and 2, all elements are same but these two sequences are different, are not equal, because the zeroth position of f of n is at 15th, that means first element of the sequence, and in g of n it is at 4, that means fourth position of this element. Therefore these two sequences are different. Suppose f of n equal to this sequence and this upward arrow is not given here, that means we consider this is the first term at the zeroth position. Now second type of the representation of sequence is general form. That means here f of n equal to 1 upon 3 to the power n, which is the representation of these terms. Suppose we substitute here from minus infinity to infinity, we consider some values here, dash, 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 and here n equal to 2, then we get 3 square plus, then comma, for n equal to minus 1, we get 3, then 1 for 0, n equal to 0, n equal to 1, we get 1 by 3. In this way, we get a value. This is the listing method. Now, we discuss the definition of Z transform. Z transform of a sequence f of n, it is denoted by fn, is defined as Z transform of f of n equal to summation n equal to minus infinity to infinity f of n z to the power minus n, and it is denoted by capital F of z, where this capital Z is the Z transform operator. If we compare with the Laplace transform, here Laplace transform is given by Laplace of f of t equal to integration 0 to infinity this e to the power minus st f of t dt equal to capital F of s or f bar of s. This is here integration 0 to infinity, that means one-sided Laplace transform we consider here. Now the capital L is the Laplace transform operator. When we applying Laplace to t domain, it converts into s domain. Therefore here f of s value, here f of z value. Here discrete function in terms of Z transform, therefore here we write down in terms of summation. Whenever continuous function, here integration 0 to infinity Laplace transform is there. Now small z is equal to r e to the power I omega. This series of the definition of Z transform is the Lorentz series, because it contains this Z transform contains the negative power of the terms as well as positive powers. Therefore, we call this as Lorentz series. And this J transform represent analytic function. Analytic function, that means it satisfies the CR condition. CR means Cauchy-Riemann condition. Therefore, del U by del X equal to del V by del Y and del U by del Y equal to minus del V by del X. These are the Cauchy-Riemann conditions. Now inverse J transform. Inverse J transform is given by Z inverse of capital F of Z equal to F of N. Now we find out the J transform of f of n. Here we consider one sequence whose nth position is at third place. That means n equal to 0 at 4. Now we write down the values of n in left hand side as well as in right hand side, and we write down the J transform of f of n. Here first element is 10 for n equal to minus 2, therefore 10 Z square, plus second term here same one, and for n equal to minus 1, therefore z to the power minus of minus 1, that means here z. Now next term is 4 for n equal to 0, therefore here 4 into z to the power 0. Next value is 1, 1 into z to the power minus of 1, because n equal to 1. In this way we write down the values and find out the Z transform of the sequence. Now secondly, we find out the Z transform of this general form, that means f of n equal to 1 upon 3 to the power n for the values of n minus 2 to 2. We write down this sequence for f of n equal to these values. For n equal to minus 2, we get this value, n equal to minus 1, n equal to 0, n equal to 1 and n equal to 2. Therefore, f of n equal to this, and apply same method as previous problem. We write down here 3 square z square plus 3z to the power minus of minus 1 means 1. In this way, we write down the Z transform of these generalized form. Now, Z transform of unit impulse function. This delta of n is given by 1 when n equal to 0, and when n is not equal to 0, its value is 0. Therefore, again apply the definition of Z transform. All values are 0, only we get for n equal to 0, its value 1. Therefore, Z transform of delta of n equal to 1. And if we write down this formula in the form of Z inverse of 1 equal to delta of n. Next is Z transform of discrete unit step function u of n. Its value equal to 0 when n is less than 0, and when n greater or equal to 0, its value 1. Now apply the definition of Z transform here. Summation n equal to 0 to infinity before all the values are 0. Then here 1 into z to the power 0 plus 1 into z to the power minus 1, 1 into z to the power minus 2, and so on. If we write down these terms, we get 1 plus 1 by z plus 1 by z square, and so on. If we observe, the common difference of these terms is 1 by z, and first term is 1. Therefore, we write down z transform of u of n equal to 1 upon 1 minus 1 by z. If after simplifying this, we get z upon z minus of 1. This is the formula for finding the Z transform of unit step function, and we write down this formula in the form of Z inverse. Then we get this Z inverse of Z upon Z minus of 1 equal to u of n. Now properties of Z transform. Here first property is linearity property. Z transform of f of n equal to capital F of z, and Z transform of g of z equal to g of n equal to capital G of z. Here C1 f of n, Z transform of C1 f of n plus C2 g of n. If we apply the Z transform here, this C1 and C2, which are the constant values. Then f of n and g of n, this complete value, if we consider these and apply the definition of Z transform, then C1 and C2 we can take outside the summation sign, and remaining term we write down as C1 Z transform of f of n plus C2 Z transform of g of n. Now this Z transform of f of n can be written as the value capital F of z, and Z transform of g of n, which is written as capital G of z. The same formula we write down in the form of Z inverse. Next, change of scale property. Here, if Z transform of f of n equal to capital F of Z, then Z transform of a to the power n f of n equal to capital F of Z by a. Now here, by definition, we consider the Z transform of f of n, write down equation 1, this value equal to capital F of Z. Then instead of f of n, we consider a to the power n f of n. Therefore, we write down here a to the power n f of n instead of f of n, j to the power minus n. In next step, we write down this a to the power n in the denominator as z by a to the power minus n and substitute z by equal to u. Therefore, f of n u to the power minus n summation value as it is, and its value equal to f of u. And lastly, we substitute the value of u equal to z by. Therefore, this is the change of scale property. Now, z transform of a to the power n f of n equal to capital F of z by a. If we write down in the form of z inverse, we write down this way. And here, similarly, we can find out z transform of e to the power a and f of n, its value. Here, this complete value we consider as e to the a, and then a is replaced by z is replaced by z by a, therefore this term. Similarly for second term. In this way, we apply this property. Thank you.